So the question here is to determine the convergence or the divergence using an appropriate method. So we start with question A. This involves a term e raised to n. So what we are trying to do is to get a bn which is greater than the given an is 1 by e raised to n, but I'm going to start with e raised to 2n. E raised to 2n can be written as e squared the whole raised to n, which is greater than 4 raised to n. E raised to 2 is like 2.73, so e squared definitely is going to be greater than 4. So I say e squared the whole raised to n is greater than 4 raised to n. Now what I will do is, to get our an, I need to take reciprocals. And when you take reciprocal, the inequality flips. So it was greater than, and when I took the reciprocal, it became less than 1 by 4 raised to n. So this is my an, and this is going to be my bn. So I can rewrite this 1 by 4 raised to n as 1 by 4 to the power of n. The reason why we consider this way is because 1 by 4 raised to n means 1 by 4 as a sequence when I write it, as a series when I write it, it's going to be 1 by 4 plus then 1 by 4 squared, then plus 1 by 4 cubed, and so on, which is going to be a geometric series. So I apply sigma on both sides. So when I apply sigma on both sides, this is sigma of our an, and this is sigma n is equal to 1 to infinity of our bn. But this series is convergent. This is a geometric sequence series with common ratio less than 1. And so it is convergent. Modulus of r is less than 1. Common ratio is 1 by 4. So modulus of r is less than 1. So what we have got here is that sigma n is equal to 1 to infinity of bn is convergent. And our an is less than bn. And if bn is convergent, then an has to be convergent. So we say sigma n is equal to 1 to infinity of 1 by e raised to 2n converges by comparison test. We look at the next question. This is B. If I look at this question, sigma n is equal to 1 to infinity of n square by 3 into n plus 1 into n plus 2. That's our question. But if you notice, I started with taking limit of it, limit n tending to infinity of that an I have written. I have a specific reason because I can see certain things happening here. If you look at this rational fraction, numerator has n square, and if I expand the denominator, that also has an n square. So if the numerator and denominator is of the same degree, now I can think of dividing both numerator and denominator by n square. And so what would happen is, in the numerator, when I divide by n square, it's going to be simple 1. The denominator, 3 stays there, n plus 1 into n plus 2 divided by n square. So what I have done is, I took one n inside the first bracket and the second n inside the second bracket. So n plus 1 gets divided by 1n, which is 1 plus 1 by n, and n plus 2 gets divided by the second n, which makes it 1 plus 2 by n. And here when I apply the limit, 1 by n goes to 0, 2 by n goes to 0, so I'll be left with 1 by 3. The limit of it is 1 by 3. Look at that. The limit n tending to infinity of our an is 1 by 3, which is not equal to 0. And if the limit n tending to infinity of an is not equal to 0, we say the series is divergent. It diverges. That's the test of divergence. If limit n tending to infinity of an is not equal to 0, we say the series diverges. at the next example, question 3. See the sigma n is equal to 1 to infinity of 3 raised to n plus 2 raised to n by 6 raised to n. That's something very interesting here. This has a numerator has a binomial, the denominator has a monomial. And when you get a plus b by c, we tend to write like a by c plus b by c. I can divide them separately. And if I divide them separately, it's going to look like 3 raised to n by 6 raised to n plus 2 raised to n by 6 raised to n. Now this 3 raised to n by 6 raised to n, I can write as 3 by 6 the whole raised to n, which will make it 1 by 2 raised to n, and this is going to be 1 by 3 the whole raised to n. So this series now split into two. The first series, if you see, it's going to be geometric because it is 1 by 2 plus 1 by 2 square plus 1 by 2 cubed plus 1 by 2 raised to 4 plus etc. This is going to be geometric with common ratio less than 1, so going to be convergent. This is going to be convergent as well, geometric series test. And so if both are convergent, their sum is going to be convergent as well. So that's how we check the convergence in this case. And the last example, the sigma n is equal to 1 to infinity of 1 by n minus 1 by n square. We split it into two questions, and when you split it into two questions, you have this first one, sigma n is equal to 1 to n of 1 by n diverges because of the p series test, p is equal to 1. While the second one, if you see, n 1 by n square, p is greater than 1, and p series test says if p is greater than 1, it converges. So if one of them is divergent and the other one is convergent, the whole given series becomes divergent. So the given series is now divergent.